Now, it's quite possible that during the course of this video, you're going to need to pause so you can catch up with your writing. I'm going to move a little bit quickly as I'm writing um, because I want to keep the video as short as I can, but please feel free again to pause, rewind as much as you need to. As I'm solving these, the first thing I'm going to do is to get this logarithm by itself. I know that my property of logarithms, one of them says that, hey, when there's this 2 times the logarithm, I could move that and make that a 7 squared. So this really is the log of 7 squared, the base 10 log of 7 squared, which is 49. And I'm going to add 2r to move my variable to the other side, equals 2r. So r is going to be the base 10 log of 49, and then divide that by 2. And to 3 decimal places, that means r equals 0.845. Please make sure you have punched that in your calculator and that you can get that answer correctly. I cannot stress this enough. This is not negative m. It is the opposite of m. You couldn't take a base 10 logarithm of a negative number, so you might look at this and say you can't do it. But if m itself is negative, then the opposite of m becomes positive. So I am expecting m will be a positive number. I'm going to isolate the logarithm. So the first thing I'm going to do is to subtract 2 from both sides. And 4 minus 2 is 2. I get stuck now in logarithmic form, and when I get stuck, then I switch to exponential form. My base is 10, my exponent is 2, equals the opposite of m. So the opposite of m equals 100. I always like to move my variable to the left, which means m itself has to equal negative 100. I could move this negative 6 to be an exponent on the x minus 3, but my goodness gracious, that would be messy and I wouldn't even know where to go. Instead, I'm going to divide both sides of the equation by negative 6. So I'm going to have the base 3 log of x minus 3 equals positive 4. I'm now stuck in logarithmic form. Even if I use the change of base formula here, it would be the base 10 log of x minus 3, and I wouldn't know what that is. So I'm going to go to exponential form. 3 to the 4th power equals x minus 3. Then to solve for x, I would add 3 to both sides. So x is going to be 3 to the 4th power plus 3, which means x is going to equal 84. I could do a lot more work than I need to here, but I know that anything to the 0 power equals 1, which means 2x plus 3 just has to equal 0, because then 4 to the 0 power equals 1, which means 2x equals negative 3, so x equals negative 1.5 when I divide both sides by 2. Likewise, 243 is a perfect power of 3, because 3 to the 5th power equals 243, which means 1 minus 2x would have to equal 5. Subtracting 1 from both sides, negative 2x would have to equal 4. Dividing both sides by negative 2, x would equal negative 2. Now I could solve these things by changing them to logarithmic form and then using properties of logarithms. In this case, though, they work out perfectly and it's shorter, and I'm lazy. I want to isolate the thing that's being raised to the exponent first, so I'm going to add 5 to both sides. E to the x minus 1 power equals 10. Now, I'm stuck, so I want to change this to logarithmic form, but my base is e. The base e logarithm, you don't write this way. The base e not logarithm is the natural log. So the base e logarithm is a natural log of 10 equals x minus 1. So x is going to be the natural log of 10, and then add 1. And then to 3 decimal places, x equals 3.303. Again, I want to isolate the thing with the exponent or isolate the logarithm, whichever way I'm doing this first. I'm going to divide both sides by 5 to get 18 to the 6x equals 5.2. I'm stuck now in exponential form. So now I'm going to switch it to logarithmic form, which means the log base 18, since 18 is my base, of 5.2 equals 6x. I'm going to use my change of base formula here and then divide both sides by 6. So it would be 6x equals the log, base 10 log of 5.2 divided by the base 10 log of 18, just using the change of base to evaluate this part. But then I would have to divide both sides by 6 to isolate the x, so then divide that by 6. I'm going to do this all in my calculator all at once to get as close to an accurate answer as I can. I'm rounding, which means I am introducing some error, but I'm going to wait till the end to round. So x equals 0.095 when I punch that in my calculator. Again, isolate the thing being raised to the exponent first, so I'm going to add 5 to both sides. 11 to the n minus 8 power equals 59. I'm stuck now, so I'm going to switch to logarithmic form. The base 11 logarithm of 59 equals n minus 8. Using the change of base formula on this part is going to give me the base 10 or natural log, I just usually the base 10 log of 59 divided by the base 10 log of 11. And then to solve for n, I would have to add 8 to both sides. So n equals this. Plug it into your calculator carefully, and you get n equals 9.700. It's longer than that, and it asks you to round to 3 decimal places, so you do need those zeros in there to be accurate.